are back. Regular scheduled program. Oh, man. What should I look up? You got till 12, bro. Or the 11. Okay, so... Okay. Hey. Doing good.
If you didn't come, we would have had a problem.
Yeah, there would have been a problem.
Let's start.
What are we doing? 4.8, 4.9.
Huh?
What are we on? 4.7?
3.
Oh, 3, not 4. Sorry. Sorry. 3. 3.8, 3.9.
Yeah.
4.4.
I think it was 3.8. Or was it 3.7? 3.7, 3.8. Yeah, it was 3.7.
Whatever had a lot of words. That he did. What did he just?
3.7, 3.8. Wait, or was it 3.8? No, 3.7, 3.8. You're supposed to teach us that too. That's what Tolu says, because he's the one who
Because he did what
us.
he says.
He's the one who teaches about it.
What?
He's the one who teaches 3.7, 3.8.
What is it about?
Huh? It's what is it about? Hold on, give me a second. Let me go to it. It's word problems. It's instantaneous rate of change and proof.
Oh, those things. I don't like them.
See, he's the one teaching us. So he doesn't like it either.
Let's try.
You don't like that either?
My teacher is crazy. You don't like them because it was hard?
Please don't tell me it's
I
hard.
think when I was taking quant, I didn't give time to study more. When it came there, like it was an optional question, so I didn't do it.
It's either you do it or not. You get a 0.
I mean, I understand the topic. It's not that hard, but I don't like it.
Smile back at tuning again. Early in the morning. As soon as they open.
So, did you come here last week Friday?
Yeah, we did. No, we did.
What did you study?
We just did our math homework and then we left.
Yeah.
Well, we to do your math homework.
Yeah, because we needed help. Like we were doing it the day before.
Okay.
We were doing it the day before and then we got stuck on like 4 problems. So then, Chloe helped us with that, and then we didn't learn anything because we didn't feel like it, so we left early. So we all left early.
That was lucky a mistake though. You should learn something.
Yeah, you think? You were here tired. You were ready to go.
You didn't object to leaving early though, did you?
I think I was tired too.
Exactly, we were all
Oh,
tired.
did we have bio that day? No, we didn't. What did we do that day?
We had bio.
No, got canceled that day.
I think we were just tired for not having bio.
Friday.
We were working during bio.
Oh, we were doing our math. No, we weren't. We were doing Alex. We were doing something.
We were doing something. We're always doing something. Oh, look, that's my 9:30 wake up alarm.
You wake up at 9:30. You're really fortunate.
Not today. All my classes got canceled today. And you know where I am? Here.
No, it's not. There's no such thing as that. No.
Does you have 3.7, 3.8?
Do you have 3.7 and 3.8?
There's a 3.10?
Yeah, 3. No, I'm sending 3.7, 3.8 too.
There's a 3.10? Yeah.
Of course there is.
Have we learned 3.7?
Have we? I mean,
What's 3.7?
that's it, right?
We better have learned it. Our exam's on Monday.
Next Monday.
Yes. Yes.
Wow. That's so cool.
Yes. Right after.
Ask your teacher for extra
Right after
credit.
part weekend.
She already said so. There's no extra credit.
She said it.
Yes, there's no extra credit.
Yeah. She told us that she was gonna give us extra credit one time, and then she was like, "I'm just kidding," and she laughed in her face.
Yeah, she said
She
so.
laughs. She
She
really
was
laughs.
laughing. Like, oh, you really believe me?
Oh, I wish there was something.
Okay, I just sent it. She really laughed.
Yes, she did.
We were literally outside the door and walk in. She said, "Psych, nah, I'm just kidding. No extra credit."
Not so
3.10.
You want to see what?
3.7. If we learned it. I hope we have. Or we kind of couldn't.
No, I think this is what we're on. Is it? Can you see? Oh, what happened? Oh, I went back. See, sorry. Still trying to get used to this.
It's okay. I do that.
3.8.
No, we're on this. We're on 3.7, 3.8.
Oh, we haven't done it yet?
No. Remember? This is what he was looking at. He's like, I don't want to. Wait, no. No, we didn't do this. This is what he was looking at, and he didn't want to do it. You don't remember? It was yesterday. So we read.
Oh, I remember. I'm just,
We filed.
yeah.
I can't even remember.
So
Is
that's
this? What is
3.7.
this? What?
Oh.
This is game. Cause why is it here?
But that's only, okay, 3.7 is
It's short.
short. But
So we just need to
3.8,
do practice problems for.
all of everything, actually.
Are you sure you've done 3.6?
Yeah, that's
No, Garden.
yeah, we did that yesterday.
Okay, they told me.
Yeah.
Okay.
You know, we practice that.
Oh yeah. You wanna do one right now? No, we don't have time for that.
We don't, we need to learn. We can practice really, really hard. Well, on Sunday.
Maybe on Sunday.
That's when we get to practice really hard.
Oh, we need to be practicing before that.
When do we have time to practice? Because we can still be learning.
No, today's the last day we're learning 4.4. That's the last day we're test.
You think we're learning 4.4 today?
She said we're continuing 4.4 tomorrow. Did she not say that? She said that. I promise. I promise she said that.
What's more to continue? Like, let's just leave it at. I
She's
understood.
gonna start the new stuff.
I'm talking about us actually having to catch up and learn things.
Yeah, but Friday's when we're gonna be done, right?
Yeah. But when do you get to practice?
Oh, you don't have Saturday. I have Saturday. Saturday, Sunday. Sorry, not to rub it off, but I will
sorry,
be-
that's not my problem. We're in this together.
We are, but I will be studying.
Everybody for
I'm
themselves.
so sorry. I will be studying on Saturday. I forget. That's why I was like, what do you mean? We have the whole weekend. No, we do that. Oh, we have to review geometry. Oh, I hate it.
I don't think it. I don't know what we're talking about.
We didn't take it. We didn't have to take it.
Well, apparently not.
No. It's like shapes, nonsense. I'm never gonna use any of that stuff. Except for now. But okay, we learned this and when am I gonna use this?
Do you think you can solve this question?
We did that in class.
We did?
Yes.
No, we did.
But
We should still solve it, 'cause I couldn't tell you how to solve it. Can we still solve it? Do you know how to solve it?
Can we solve the first one?
Wow, that's crazy.
You done?
Yeah.
Oh, that's good.
Just for A, right?
Mm-hmm.
3t squared minus 12t plus 9, right? Is that right?
You could probably do that differentiation.
What'd you say?
You really do that differentiation.
Oh yes, it's easy. It's fun. This is
Because we
fun.
had to learn it in our heads. That's why we're good at it.
Can you solve the second one?
After 2 seconds? After 4? So we just
We just plug in, right?
You're done? What will you get?
Negative 3 and 9. Is that right? Okay. I thought I did some math wrong.
You're done? Try solving C.
See?
Mm-hmm.
That's right now. I couldn't tell you.
See?
See, when is the particle at rest? Would you plug in 0? What does that mean?
Let me explain the question to you. Next is the function that relates the position. So basically, the T is the time. So when we want to find the position the person is at maybe time 2,
Sorry. No, I was listening.
you sure?
Yeah.
Okay. If you want to find the position the person is at maybe time 2, you just plug 2 in. But if you want to find the velocity the person is moving, at maybe time 2, you just plug 2 in the velocity function you derive from this, right?
Yes. Oh, so you plug 2 into this?
No.
Oh.
So when a particle is at rest, it means the velocity is what? 0.
Mhm.
It's not moving.
Mhm.
So you have to equate the velocity
Oh.
function to 0 and find the speed time.
So like this equation equals what? Or
This
this?
is position, but the velocity equation you derive.
Oh, we're doing it for velocity.
Yeah.
Hey.
So that velocity equation you derive, you equate it to 0. That means at that time, the speed is 0, then you find c. You're done?
No. You're done. Oh, the minus.
You get 1 and 3.
That one.
That's right. So basically, it means at time 1 second and at 12 seconds you stop.
Okay.
Yeah.
Oh no, I was done. I just didn't. I had a mistake.
Okay.
Yeah.
You had a mistake. How did you get 3 and 1?
No, I got it right.
Then where was the mistake?
Oh, because I had a plus 1, so I had -1.
Oh, you had
Yeah,
it.
I did the, yeah.
So basically, when it's moving forward is when the velocity is positive. So you know that it started from 0, moved in a certain direction, they don't know yet. And at 1, it stopped, right?
Mm-hmm.
Then it's moved again, you don't know it might continue moving forward or it move backward or whatsoever. And it stopped at 3, and it's moved again. So if you want to find a time where it was moving in a positive direction, you analyze from when it started to when it stopped. Is the velocity positive? And in between 1 and 3, when it went again and when it stopped, is the velocity positive? And 3 and any number greater than the velocity positive. So the velocity function, you put any number less than 1. Because if you put 1 in, you get 0 to stop at that point. You put any number less than 1 in there. And if it's positive, it means it was moving in the positive direction, or it was moving right at that point. And in between 1 and 3, find another number and replace it there. If it's negative or positive. If it's negative, it was moving left, so it was moving in the negative direction.
Mm-hmm.
And if it's positive, it was moving right. And you do same for 3 and any number above 3. So all the intervals where you find when you get positive numbers, it means it was moving right. You don't understand? You don't.
You plug in, you just said plug in a number less than 0, right? Is that what you said? And
It started from 0, right?
yes.
It moved. And it stopped at 1.
Mm-hmm.
And it's moved again. And it stopped at 3. And it's moved. So we want to know maybe when it started from 0. When it started from 0, it's moved to 1. And it's moved to 3. And it's continuing moving. But it can also start immediately when it started from 0 and it's moved to 1. It's moved back and it stopped at 2 and it's moved forward. So we want to know the times when it was moving in the right direction, in the positive direction. So if it's moving in the positive direction, the velocity should be positive. So I will take any number in between this, when it started to when it stopped.
Oh, okay.
And we check if we put it in a velocity function.
So like 0.5?
Yeah. And we calculate for C. No, I'm sorry.
We do the different.
We put it in place of C, then we find the value we get. If the value is positive, it was moving right. If it's negative, it was moving left.
Okay. You have
Then
to do it for this too.
Yeah, we do it for this and around too.
And the last one?
Yeah, and the last one.
You said 3.5?
You can put 0 if you want, that's easier.
Did you put 0 too?
But don't put 1
Why?
because
It's not.
because
Because
it
it
stopped
stopped
at
at
1
1.
and stopped at 3.
Oh. So it would be 9. This is D.
We just substitute
Mhm.
0 for
This guy's pressure is something like
Oh, did you do 2?
Can we do 2?
it's yeah, in between 1 and 3, yeah.
Oh, because it is between. Oh, then that's all you have to do? You don't have to do another one?
No.
You just take 1 in the interval, then you check.
There's 3 in one though.
Yeah.
You said we had to do that.
from 0 to 1, 1 to 3, and 3 to
3, 2, oh,
infinity.
we're good.
So you just choose a number and then you value.
Yeah, a number greater than
Wait,
0.
do you need help or are you just working?
No, I'm just working. Yeah. At least for now.
I chose 5. There.
So can we just use this?
Is that a velocity and a position?
This, huh?
Oh, I think, yeah.
We can use these, right? We don't have to resolve, yeah. That's what I thought. I was just gonna.
Yeah.
Huh? No, we know what we're doing, so we don't need to do extra work. Remember, that's adding time onto your negative time on the test. You need all your minutes.
I got this question. Watch this video. I would actually like it this one.
Yeah, this is key like work. She's not that nice.
What do you get?
Mine, negative 3, 1. You got that right?
From 0 to 1, is it? Okay.
We're going to the right, and then moving forward. 1 to 3 is moving to the left.
1 to 3 is moving to the left.
1 to 3, moving backwards.
Right?
Yeah. Cause negative.
Oh, yeah, that's true.
And then 3 to infinity is moving to the forward.
Hey, don't put moving to the right. She's gonna mark you off.
She knows what I mean.
No.
Okay, fine. It's moving forward.
So it's moving forward. 1 to 3. 0 to 1.
0 to 1, and 3 to infinity to forward. And then 1 infinity backwards. 0 to 3.
Yeah, that's true.
Oh, we skipped that one. She's definitely not gonna get that.
Check something. You see, 1 is stopped. So there's no bar here. It's less than 1. For 0, it was positive. I don't know if you get what I'm trying to say.
No.
I mean, it stopped at 1, right? So there was no motion at point 1, right? And there was no motion at point 3, right? So the places where it's moving positive, in the positive direction for this one, is when t is greater than 3. Agree? You cannot write when t is greater than or equal to 3 because at point 3 it stops. Yeah. And at point 1, at point 0 it was moving in the forward direction.
You reach a point 1 and then stop.
Yeah. So like this, the 0 is included. And it stops at 1.
So that's how you
It
write
stopped
the
before
answer.
1. Yeah.
Is that right answer?
So this is that.
So if I don't write the answer like that.
I mean, you can write it in words, but you need to be very specific. That from point 0 to before at from time 0 to before time 1, it was moving forward, and after time 3, it was moving forward. I think that this is easier.
This one.
The diagram was just us following this.
Sure, then I'm going to present a
Mm,
motion. I mean, you just put values in here, then you plug the values you get after you, maybe if you put the 0 here, that's for time t, so 0 will be the x part, and then whatever value you get here will be the y part. And you keep plugging in 0, 1, 2, 3, then you draw the diagram. So it will be this position versus this. Do you get what I'm trying to say? No.
We have to do this? Did I?
most likely she won't break it in the result.
She said she won't.
She
Yeah,
won't.
she's not good at that.
Yeah.
We
But
didn't even go through this in class. She only did like the first two.
just the first two.
Yeah.
You sure?
Yeah, I'm
Well,
sure.
no, she did it D.
Did she?
Yes.
Oh, you remember?
Yes.
Okay, so let's skip the rest of it. Okay.
She didn't tell us we had to finish it, did she? No, she didn't. I don't even know what that is anymore.
What I'm trying to say is that they want to represent this motion. Right. I think motion is
Still
velocity,
not represented.
not position. Yeah, let me confirm.
She went to the next one.
It's velocity. So basically, the velocity function we have to look through is square minus 12t plus 9. You put values in here. So you start at 0 and you put 0 here. When you put 0 here, you put 9. So your x as a 0, 9 is something like this. And you put 1 here. When you put 1, you get 3 minus 12 plus 9, which is 0. So your 1 will be something like this. And you continue plugging it. Yeah. And this part will be time. And this part will be velocity.
Oh, so it's like the
Velocity time graph.
like the biology kind of thing. So it's
Biology?
the graphs that they be drawing.
Can you
Scatter.
look for
Giving stats.
F?
What all this is?
Where's that? Give me those 5 seconds. So we'll be plugging 5.
It won't work that way. Wait,
Total is.
are you taking fitness?
Which
No.
day? No.
No. Have you ever heard of displacement and distance before?
Biology?
Yeah.
Mm-hmm.
Briefly.
They didn't talk about the difference between displacement and distance.
I remember learning.
Oh, do I remember? No. Do I remember it?
Do you want the distance right? So, assuming I start from here, right? Assuming I
Sorry.
start from here, let's assume the distance between here and here is what? 5 centimeters or something. So if I walk from here to here, I've walked how many centimeters? 5 centimeters, right?
Mm-hmm.
If I come back, how many distance did I cover?
The same.
Yeah, I covered the same when coming back, so the total is what, 10.
Oh, okay.
But you see that if you put what I just did in this function, I'll get positive 5 here, and I'll get negative 5 here because I'm coming back, right? Like I'm moving the left direction. So that with distance, you put the absolute values of all positive parts because we don't care about negative, so you just take positive. If you just put 5 in here, it will give you the displacement. With that, the negative, with that, when you're coming back, it will be subtracting. Because displacement takes into consideration of the direction, so when it's coming back, it will subtract. But distance does not care. So whether I go forward or I come back, so far as I change my position, it's added, it's not subtracted. It looks like
Wait, so this, sip this. Sip that coffee.
So basically, what you do is these intervals. You put one in there, in this function because
So
now,
one in there.
yeah, wait, yeah. So
The main, the first.
yeah, you put one in the position function. This one.
Oh, sorry, I was trying to solve it in my head. No, I was solving that. I was paying attention.
Okay, so
I can't solve it.
you put one in here, so you basically find f of 1 minus f of 0. This one. F of 1 minus f of 0. The absolute value of that. You want to find a distance from moving from here before
That's
you
how
stop.
this is for all this? In between all this?
Yeah. Plus f of 3 minus.
Basically
f
what we
of
found
4.
already.
Yeah, you
We're using these values, right?
No.
Oh, never mind. These
Back
ones have
to
to
the
get rid of
original.
them.
Plus
She's not this will
f
take
of
the
5
whole
minus
quiz.
f
The
of
whole
3.
exam.
So check. They want it up to 5, right? So there's another.
Okay, because now they're playing.
So there's another interval here which is 5. So I took f of 5 minus f of 4. Absolute value. Why I'm bringing this absolute value is that we've already
Because you said we don't take negatives or system.
So-
Yeah.
exactly. So you basically evaluate this and the answer you get will be the answer.
My friend up.
We're not doing that, are we?
No.
Okay.
We need to learn. We only have 2 hours left.
We're learning.
No, it's 3.7. Is that 3.7? I mean, that's still 3.7. Let's move on to
Yeah,
that.
that's really fun.
You can find the acceleration, right?
Yeah, you just differentiate the velocity
Okay.
again. And it's 16 minus 12.
Light work.
And for this one, when is the particle speeding up and when is it slowing down?
We'll just do the same thing, right?
Not really.
Of course.
You have acceleration and you have velocity. When the velocity speeds up, it will have the same sign as the acceleration.
You said what?
You should have been taking physics.
You said we should be taking physics
Yeah.
to understand this class?
No.
Oh.
But I mean, these are like in physics, so it will make things easier.
Wait, if this is in physics, why are we doing this in calculus 1? Who created this course?
I don't know. But like, if you say somebody is moving fast, you understand that, right? He's moving fast.
Yeah.
It means that he's increasing his speed,
Mm-hmm.
and that is acceleration. You're increasing your speed.
Mm-hmm.
So basically, if I'm moving in this way and I start increasing my speed, the acceleration figure I will get and the velocity figure will have the same sign. Just memorize that for now. Because
Memorize what for you?
I said
Memorize that for now.
just memorize that
Oh,
because
okay, sorry. I thought you said memorize something.
though I can explain in details, but I feel it's not worth it.
Yeah, I don't think
Yeah, we have to move on. So
But she's not playing this one.
okay, so let's
See?
move on.
But the first question always shocks us. First question is always something like this.
No, there's no way she would put. This goes all the way to I. This is the whole alphabet.
Maybe she just takes some parts.
The easiest parts. Okay, we might. She'll probably give us one where you have to find the velocity and then the acceleration. You know what I mean? But I don't think
Yeah,
she'll
I
make
guess
us plug in
moving
points.
forward. When is particle moving forward? When is at rest? And then
She probably will do that, right? Oh no, she probably will.
acceleration.
She won't do the one that we just did though.
How no?
This
I
one.
feel like if she's
She's not gonna do
mean,
this one.
why is not? Why not? I feel like she would.
Because it's his work.
No, it's not. When is the particle moving
She's
forward?
not gonna do that.
That's not too much work. If she's doing me, she's gonna do this F.
This is definitely the first question.
Well, no, not this. 'Cause we
Okay,
learned
no,
more
this is at the
complicated
end, I
things
forgot.
after.
This is what we do.
But we ended at 3.7. That would be the next question. We end at 4.4.
She's actually playing games. What do you mean? Why are we going into chapter 4? It's supposed to be chapter 3 because exam, not quiz. What is this? Why is this heat? What is this? Heat?
You mean the change?
This is a symbol.
That's delta.
No, I'm thinking chemistry.
Yeah.
In biology.
That's changed it.
What is this? Doing here.
Yes, we care. Of course we care.
No, I said, what is it doing here?
Okay. It says current. Called the current. Okay, now we're doing too much.
She didn't even do this in class.
No, she
What?
would.
You said she did?
I think no, she didn't.
She didn't.
I trust you more than me.
Because I paid attention?
Yes.
You paid attention last class.
Yes, I did. Because I understood what was going on.
And then I think that
Is she asleep? No.
Are you ready?
Off the jets.
Yeah, I'm ready, but like, I honestly don't see the point in all
of this, we don't need to do this, right? Okay, skip it then, skip it. Anything you think you need to skip, just skip it.
You see, you say that, and then when it
If
shows
she-
up on the test,
If she, okay, if this shows up on the test, I'm gonna be like, you didn't go through this, you didn't teach this, so go.
No, like, I mean,
is it just like that?
No, it's not. It's not.
let me
She-
show you the whole idea.
Okay.
But she's giving like some specific examples that are not limited in calculus. These are all things.
That's what
Okay,
she,
so it's not really
cause she didn't go through it in class, so.
No one that she didn't go through. But these are just like elaborations, just trying to explain further.
Explain what?
Feather? Feather?
Wait, how did this? How did this spell it?
Feathers like bird feathers? What is that?
Not this.
Not that. Further?
Oh.
No, I heard
Oh,
feather. I was about to say
explain
feather.
further. Oh, sorry.
I'm so sorry. That's
Okay.
my bad.
So basically, this is the whole idea. You have something, let me say, a function.
Mm-hmm.
And this is the graph of the function. X is here, x1 is here, and it changes to say here, x2. This is y1, y2.
Mm-hmm.
You can find the change here, which is changing x, right? And the same for y is changing y.
Mm-hmm.
But you remember this formula?
Yes.
That's what the slope, right? That's basically what it's saying. And when we talk of rate of change, I think, except they specify, when they say rate of change, they mean as that thing is changing with respect to our time. So if we have a function, then we they want to find the rate of change of y is the y, the t. I mean, as this whole function is changing with time. So normally for something like this, they'll give it t squared plus 15t plus 6. Like they will place the x with c. And that's similar to what we did here. And he's giving you some examples in other branches. This is
Okay,
physics.
great. You can skip all that.
This is chemistry. This is biology. Like,
Yeah, no need to. We're not. Yeah,
Please,
we
don't
seen
need
enough.
the classes that we're struggling with to show up in the
Wait.
class that we're struggling in.
I read them like, I don't remember the topic is paradox, but basically concentration. Like the rate at which the concentration of something is changing with time.
Like, have we done that in chemistry? No.
No.
Not yet. Oh, I
We're
think
barely
it's
on
going
like
to-
gas laws.
Yeah, it's going to solve.
We know growth rate.
So basically, this is the rate at which the concentration of something. I mean, I don't need to explain concentration. It's not that long. The rate at which it's changing. So just say that when you have maybe the y over the t, the c over the t, the whatever over the t is the rate at which the thing on the top is changing with respect to time. That's basically all that it means.
Please, I will read this 3.7 on that test. Hold on now. Go to the
It
email.
is.
No, where's the
Let's
email?
go here.
What we think on that test? Wait, do you remember the notes that you were taking about what she said? She was saying.
You sent it to the picture, didn't you?
I don't know.
She said, in physical differentiation, log differentiation, instantaneous rate of change, one question, one related rate, linear approximation.
Is this the one coming with this? So let's see.
3.7 to 3.9 instantaneous rate of change in related rates. I think she's gonna give us something from related rate.
What's related rate?
Huh?
What's related rate?
And this is the translation change. How do you say it?
What's related rate?
Is it good? Did we just learn it? Is that it?
What?
Is related rate what we just learned?
What's that?
Oh, perfect.
okay.
Perfect. Cause I was say.
Related rate.
You know that.
From
Oh.
Are you off the bed? No. You have to get up and do work. You need to get up and get ready for the day. I'm not making you until you get up. You need to say proof that you're on and off, remember? Huh? But you made me do it. You told me to. Think about how you're gonna pass. Understand? Because you're gonna sleep.
Are you taking Spanish?
I only take four languages, 4 years of language.
Do it have to be all? It has to be 4 years of Spanish?
No, it's 4 years of foreign language.
So I could just switch different languages?
Oh no, I think it's 4 years of that one.
Really?
Yeah.
You said you have to what?
You're done? Okay. Like when you done
I'm not going to Spanish.
Huh?
when you're done talking to
No,
Oh,
you're
okay,
ready.
okay. She's good. She's gonna stay here until she wakes up. She'll join me like 2 minutes.
you sure?
She joined
she
yesterday.
Yeah, she did join yesterday.
Oh
Not to learn, but she was just
no, I thought she's joining now. I was like, how?
How is crazy. Okay.
So like what I said, everything here.
Oh, same thing your birthday.
Hmm?
Is it the same thing you've been explaining?
Yeah, but basically if we have the y over the t, that's the rate of change at which the rate of change of y. So here he was talking about a specific example which came in one of my exams. The rate at which the population of maybe a city or town whatsoever is changing with time. Since it's changing, if it's changing at a constant rate, the rate at which this is changing will be the former population times the constant is changing with. Do you agree? Like, does it make sense? The number of people in a particular country maybe is changing for maybe every 2 seconds. It changes by 4
Okay.
by 4 times. So like the k is the 4 times. So this is the constant at which is changing.
Mm-hmm.
Yeah. And with this you can make k the subject. When you make you can make k standalone. Kp. If you make k standalone, you get the p over dt times 1 over p equals to k. Do you agree?
Oh, you're just rewriting the equation.
Yeah, making k standalone.
Okay.
And we call this our relative growth rate.
Okay.
And
Can you just withdraw from me? She got so scared.
No, all this work would have been for nothing. Exam stress, time spent in tutoring.
I think that's basically all you need to know before we start solving
I
questions.
hate this stuff. I
Wait,
hate
do we have to memorize? Huh?
No, we don't.
I'm asking the tutor.
I mean, it's not hard. Like, you have this duplicity, which is equal to the constant times p,
This is
and just
reminding me
make
of
k is the subject, and you get this. And this is called relative growth rate.
Okay.
See, I don't remember her doing any of this.
She didn't.
She didn't?
She did not. Let's just talk about she's gonna put that on the exam. She did not talk about this in class.
So we should skip it?
No. Should we?
No.
I want to.
No, it's literally said that.
Okay, we can just do one little pause.
Yeah, one
How-
example.
She's gonna put one of these as a first. She always puts what she doesn't talk about as a first question.
I mean, these are open, so we can skip these if you want.
This
Is
is
what?
Newton's law.
Physics? Oh, no
What?
physics.
See,
Newton's law of
she
cooling.
just added
Newton? I don't want to hear
She
about
just
him
add this
anymore.
in for fun, because what do you mean we're talking about physics and calculus fun?
I don't want to hear about him until I get to those big stairs
But
in the valley.
this question is really important, so
Oh, this one? Oh, she's gonna put that. That's the first question, actually. We're looking at it. We're looking right at it.
yeah.
Oh, gosh.
So read this and
What
try
is
to
it?
understand.
This,
Yeah.
How are you gonna understand it? First. Well, he might have to. Oh, you're I just saw that picture you took of me. That was so nice of you, Kaylin. Loki, have to make this in stickers, please.
No,
Don't
no.
send that to Gary.
no, for real.
Huh? Okay. Like, it's giving confusion at its finest.
Did she get a ticket?
Oh, she here? She there? No, she's
Oh.
Oh, that's not.
So you have to screenshot.
It's my finger has to be like this.
Are you? Never fell. Wait, you see? Okay, I like it.
No,
Delete,
not that one.
delete.
Not that one.
We'll just wait till she comes back.
Yeah. Just gonna have to take a picture for this. Let's do a FaceTime picture.
Is it hard?
It's not hard like when I take out all that for the stuff, bro.
Is it up?
For the stuff.
Should we ask her just to send it
We should. We can skip it.
Is she
No.
on here?
It can find me right now.
Huh?
Is it gonna be on it?
It can find me right now.
That's why it's gonna be the first question.
It's hard for.
What is this called? What is this called?
Huh? Are you back? Oh, we were trying to take a FaceTime picture. Can you
You
take
ready?
one of this? Are you ready?
What?
You ready?
Yeah.
You know what? Let's do 3.10. Wednesday when you come there, we just so I'm
When we
going
come
to-
Wednesday,
Yeah.
Okay.
our test is Monday.
Mm-hmm.
We can skip it, because we can also
That's
ask her if this is
fine,
gonna be on
that's
the test then.
No, it's a
Not you looking at it.
He said it will definitely be on the test.
No, I don't think she, we're gonna ask, I'm still gonna ask
He's just
her.
happy because he's
He
not
doesn't
gonna
have
have to
to
teach
teach.
us anything.
Yeah,
I
quick
forgot
to
to
this,
do
look
stuff,
back
so
at the
it's
quick quiz, huh?
I just need to have time to class to.
Okay, that's fine.
Yeah.
3.10.
Wait, what happened to 3.9?
Oh, you're right.
Where's 3.9? You didn't say 3.9.
I did it?
You sent him 3.9?
You just sent it.
You sure? Check again. Wait, for real? I could've sworn I did. What do you get? Pass. 6. No, I did, look, it's right here.
Not you lying on her name.
Oh.
Oh, because it filled differently. I don't know why I did that. Yeah.
No subject. No subject. Yeah. Stop being embarrassed. Perfect. Yeah. Huh? You're gonna run to Annex? Oh, you're gonna be here too. I'm looking for He would never say that to us.
No.
What?
Oh, Henry says email saying that he was looking forward to seeing us.
Me?
You would never.
What did I
Yes.
say I was looking for?
Oh,
One
that's
time
cute.
we came before our last test, yeah. And we asked if you were gonna be there.
You would never say that to us, right?
You don't want.
That's
you
not
never,
true.
No, that's
Oh,
true. Say it right
that's
now.
not
Say
true.
you're looking forward to seeing us on
Friday.
Friday.
I'm looking forward to seeing you on Friday.
Will you be
No,
there
you-
though?
I will.
Mm.
How are we doing what again? Oh, him? On Friday? Are we gonna be there? On Friday? I hope he's there. He better be there. And not in the yard. He's,
Why are you laughing?
the evil laughter is taking me out.
Are you guys doing 3.7?
Yes, and 3.8. Wait, no.
That's good.
Not 3.8.
How-
We're
how
gonna
was it?
practice 3.8.
Huh?
instead.
How was it?
It was fine. We didn't really do
We didn't really
anything.
do it.
Okay.
We didn't really do anything. The 3.8 I forgot to
Like-
stop, so I was like, we
What
should
did you
do it
say?
on Wednesday.
The guy, tutors deliberating together. Said no.
So where's 3.9? This is 3.9.
Related rates.
You guys ended to 3.9.
Yes.
Yeah, right.
He's so happy. It's like the west side of the beach though. Look at you out and going to the next. I'm so proud of you, Lynn. Sorry. I'm patting my back. Don't make it. Yeah. Okay. Well,
So this part is basically like the application of the
Geometry.
geometry and the
So should we-
implicit differentiation unit.
Okay, why? Should we like, do we need to like write down
some formulas.
for those shapes? Cause I don't know geometry.
She said
Do
to
you
know.
think your teacher will give you the
No.
formulas?
No.
She said you have to know the
Spheres,
Sphere,
squares,
the
circles,
cone, don't forget the cone. Cylinder,
cube.
cylinder.
She said the basic shapes you need
She
to
said
memorize
basic
it.
geometry. You need to know basic geometry.
She
Do I
needs
know
like,
basic
she needs like
geometry?
20 of the
No.
things talking about it's basic. Girl, what do you mean?
I think I remember some.
That's
so
nice for you.
should
I
we-
didn't take geometry.
We took that freshman
Then
year. I
it's
don't
gonna be
remember.
hard for you.
You said it's really what? Is that hard?
Hard for you.
Okay, we can just only make this like minus 25.
I mean,
No, we did not.
wait. Maybe you should memorize them because if she's not gonna give it to you, if you don't know the formula, you can do something.
Memorize what?
Basic geometry.
The
Geometry,
formulas for maybe
for the
volume
area,
of cylinder,
yeah,
poles,
all that
stuff.
things like that.
What? Would your teacher give you that?
Well,
My teacher, I don't really remember, but for basic ones, I'm not sure. But
from where I'm
for-
coming from, I was forced to learn all those formulas.
of course,
In South one.
No, in high school.
So
No.
you know it?
no, of course in Ghana they'll never give you the formulas.
Huh? You said you never? Because they don't care.
Same in Nigeria.
Never.
They don't want
You have to know all
It doesn't happen.
this
I'm sure you had to know all of them in geometry too.
Yeah, I did. No, actually, the teacher gave me, he let us use our notes.
There's volume
Are
of
you
a cone, cylinder,
Oh,
surface
so you
area.
can teach us that right now.
you. Love you.
Or tell us this, we can write it down.
Up at 10.
Or actually, you write it down, and then you give us the sheet so we can use it to solve.
No, I mean you can search online.
It's in the
or
slide.
things like that.
No, it's not, guys.
No,
The
it's
formulas?
no.
No.
When they give you the question,
This
they'll definitely give you the formula using the slides, right? So maybe area, pi, or square. There's definitely a
You meant to like differentiate the formula.
Yeah.
It's so crazy.
You have to just.
I found it fun.
And,
A little bit.
Oh, so now that's what you're gonna go because you're excited to teach now?
See?
So basically, for this related rate, it means like we have more than one things that
Yeah.
is changing with time.
Mm-hmm.
So basically, let's assume we have a balloon, and the balloon is this big, and we keep inflating it, and it becomes this big. The volume is changing on it with respect to time, and that's not only the volume. Assuming the balloon is a circle, the radius is also changing with respect to time. Yeah. So more than one thing is changing with respect to time. And when you wanna differentiate this, you differentiate implicitly. Everything that changes with respect to time, you differentiate implicitly.
Oh, that's fine. Why?
Let me show
what?
you an example.
Why?
I mean, circles don't have volume, is plain.
Wait, what?
Let's assume it was the area changing. I don't want to make it sphere to make it quite complex. So let's assume the area of any surface is changing and the radius is also changing. When you differentiate anything that changes with respect to time implicitly. you remember that implicit differentiation, maybe you have x, y equals to maybe x squared plus 5x. You differentiate them normally by differentiating y implicitly, right? So since the area will be changing with respect to time, you differentiate it implicitly. Since the r will be changing with respect to time, you differentiate that implicitly. We'll come to that when we solve example, but just note this.
But you have to differentiate each one
Yeah.
individually by itself.
Mm-hmm.
So first you do A and then you do C.
Or
Or
I just
oh,
mean
oh sorry, I can't see from you.
you do the A, the T,
First and then you have to do the next one.
like
Or you do it all together?
yeah, all together.
Oh, okay,
Yeah.
okay.
So just know this for now. Like if it's changing with respect to time, you differentiate implicitly. And
Nonsense.
for example, when water is drained out of a conical tank, the volume and radius and height are all functions of time. Yeah, so for example, for this one, we have a conical something tank, a conical tank, and water is draining out. The height or the level of the water in the conical tank changes with respect to time, right? The radius and the volume of the water, so all of these will be differentiated implicitly.
All of them?
The volume, the radius, and the height. So when you're asked to differentiate it, you differentiate implicitly. So we give it to should we just look at the solution, or we should try differentiating it to get the answer?
I don't know.
This is the formula for volume.
Of what?
Volume of a cone.
That's not given.
It's
Yeah,
basically the
not.
formula for volume of a cylinder divided by 3.
Yeah.
Which means you can fit 3 cones into a cylinder.
Yeah. You look very confused.
I'm just
I-
confused on the
I
fact
had
that I
the
have to
shapes. I
memorize
had
the
to remember
shapes.
the shapes before what?
At
Monday?
least you have some general knowledge.
Do I remember any of it? No.
You can trigger
I
it.
hated geometry with everything in my body. Hate is a strong word, but I hated it. Bro, now she's bringing, when she started saying geometry in class, I was like, what are we doing? And I just started looking like this, cause no.
Okay, look.
What did you say?
You hate every single kind of math. Because why do you hate pre-calc and why do you hate geometry? Do you hate algebra too?
No, I love algebra.
Okay, there we go. We found something she loves, guys.
That's why I came back out, cause I thought it was just something crazy instead of stats. I hate stats, it's not math.
What's the volume? Is it like the 4/3 pi r squared h? Is that sphere?
What?
Is that volume of a sphere?
Volume of the sphere is 4/3 pi r cubed.
Yeah.
Oh. Okay. I was
Surface
close enough.
area is 4
Why
pi.
are you memorizing it? Why did they make you memorize this
I
stuff?
don't know.
That's
Schooling
good,
in
though.
Nigeria was tough.
I can
It
see
was
that.
hard.
That's why you're so smart.
They shaped you from early on.
Yeah.
America doesn't do that.
Yeah, they don't do that.
This is not America, guys.
They don't take school seriously. It's a joke. It's a joke.
Their education is down too. No more. They said we don't want these kids to be smart.
Oh, okay.
I should go to Jamaica. They won't treat me like this.
I'm just kidding because every state is different.
Okay.
You know, like,
And they all suck.
yes.
So what I've been saying, we need to differentiate implicit. I mean, this is the formula, right? and we need to differentiate
R
it.
squared H.
So the VDT, I mean, if we differentiate volume implicitly.
Wait. This is just this, right? This is just this.
Yeah.
Yeah.
Oh, why'd you write it like this?
Oh, you can make it over 3.
Yeah.
And
You're multiplying,
equals-
right?
Wait, why is it over 3?
It's the same as n pi r squared h over 3.
Yeah. Because you're multiplying all of them.
Oh. Okay. Thank you.
I like to look at it this way.
I like writing it this way because it reminds
This
me
way is
that
better?
it's 1/3 of the volume of
Okay,
a
we're gonna
cylinder.
keep it this way then. Okay.
Yeah. So basically,
Oh yeah, it is too.
we know that the values which are changing with respect to time are what? Volume, radius, and
Height.
height.
Mhm.
So we differentiate volume implicitly, which is dv over dt. Agreed.
Mhm.
Equal to I would advise, okay, normally when I introduce anything, you people get confused. I would have advised that since these are not changing with respect to time, I mean, if we differentiate them, we're gonna get 0. Like, it will just make our differentiation complex because we are having
1/3.
3, 1, 2, 3, 4 multiplying. So we could have just do it simple like how they did it. Bring that one out and find the derivative of the one inside.
Sorry.
You said what?
Assume I didn't say anything, let's just differentiate normally.
You said you didn't say anything?
Assuming I said nothing. I don't know
I
how
think
to
we
say.
ran into this problem last time with total where we started differentiating this and it's like, what are you doing? It's not added, it's multiplied. Don't differentiate it.
That was yesterday.
That was yesterday, yes it was.
Okay, so
So we know not to differentiate these.
let's do everything.
Oh, but you just
Like, I don't wanna confuse you. Like, let's do what we already know.
okay.
So let's try differentiating this, and remember the product rule. We differentiate the first one.
We did product rule?
Yeah, they're multiplying.
They're all multiplied by each other.
Oh, they played. Okay.
Should I rewrite the product rule, or you know it's?
We know it, we know
No,
it.
okay, that's fine.
Differentiation of A. I mean the derivative of
So
A.
let's write it 1/3 pi first. When we differentiate it, what will we get? 0.
0?
Yeah.
Okay.
It's just 0.
Okay.
Why is it 0?
Close.
Because they're constant?
Hmm.
Why is it 0?
Yeah, because they're
Because
constant.
constants? Okay.
Yeah.
Yeah. Okay, I knew that.
And times the rest, which is also 0, right?
Oh. What's
So-
also
So
0?
the whole thing is 0 now?
Wait, what's also 0?
Wait, you said that we differentiate the first part and we multiply by the
B?
rest. Yeah,
Yeah.
B. Yeah, that's true. So 0 times B. B is r square h.
Mm-hmm.
Okay. Plus, we are
Oh, it is 0.
differentiating r square, right?
Plus.
We'll get what?
2r
2r times
times
the rest, which is h over 3, h pi over 3. Agreed.
h pi over 3.
Huh? Oh, you multiply
By
it.
the
Yeah, yeah,
rest?
yeah.
Yeah.
Wait. So we did the product rule on
Wait a
1/3
second.
and pi, and we got 0,
Mm-hmm.
and so we multiplied it.
By B, R squared.
What? Wait.
Then when you differentiate R squared H.
No, I differentiated r square. And-
Because H is not. Oh, yeah, they're separate.
Yeah.
Oh, then it's 2R.
And then
So
I'm
ours-
confused on why you multiplied the. So the b.
You multiply by.
So wait, if I'm
'cause we have
differentiating r squared, the b now is pi h over 3.
That's the d pi h over 3. Oh, okay.
H pi over 3, right?
Yeah, h pi over 3 is
Okay, yeah,
b.
that, yeah.
Agree.
But you have to multiply by everything.
Yeah.
Oh, okay.
I remember we are differentiating implicitly, so we get the out of dt.
That makes sense.
Plus implicit differentiation of h. This is what pi r squared over 3 dh dt. Check it out, agree.
Yeah.
You do? Okay.
Pi r squared h over 3. That's what you said.
Yeah.
Times.
Pi r squared over 3
Mhm.
times the h
Yeah,
dt.
because yeah.
Yeah. So the way the is equal to 2r h pi over 3 dr dt plus pi r squared over 3 dh over dt. And you have square over 3 on both sides of the equation, so you can factorize that out.
We mean on both sides.
But first of all, write this. Do you agree to this first?
Wait, can I see?
It's the same thing, but since it's adding to 0, I can add the 0. You do it very well.
Oh, yeah.
Okay.
So what are you trying to find? dv dt?
Yeah, we try to find the dt.
How you get rid of these?
Okay, so we're giving to you in the question.
Oh, like what it equals?
Mm-hmm.
So you just plug it in?
Mm-hmm.
Okay. What is it?
So like this is just the surface. I'm just trying to explain to you what I mean by you differentiate implicitly.
Oh, okay.
Differentiate implicitly.
So we're done right here for now?
Yeah, you don't really, you can just factor the pi over 3 out,
That's easy.
like what they
That's
did.
easy. That's easy.
So you get pi over 3 multiply 2r h dr dt plus whole squared dh dt, and that's the answer. What do you have here?
That makes sense.
Yeah.
Just plug it in and then you get the answer. Okay. So, but the most important part is knowing this equation.
Yeah, knowing this equation and
Is it? Can
knowing
they switch? What order we have to know about it? The shape?
Volume?
That's it?
Do we have the
Area, not like the area, but
yeah, if it's
that is.
2D, like 2 dimensions, know the area. If it's 3 dimensions, know the volume. Okay. All that I mean is that if it has a formula for volume, know it. If it has a formula for area, know it. And I think
So volume area.
for cylinder too, you have to know the surface area.
Oh, yeah. She did say that.
Yeah.
Surface area.
Mm-hmm.
Okay.
What's that?
It's her signature.
That's nice. So let's start warming up with these kinds of questions before we
This
go
is using chain rule.
into the story problem.
Alright, okay.
246. We're doing good on time.
So the examples x and y are both differentiable functions. So like this.
Oh, this is just us warming up.
Yeah. I mean, this is a trivial question. Hmm? Yeah. Have you read the question?
Oh, you guys write it?
Read it.
You said write it? All these words?
Like, have you read the
We just
question?
differentiate, right?
Oh, have I read it? Sorry, I thought you said have
Yes.
you wrote, right? Did you write it? Verbal lexicon. I'm not good at that signature.
Why does it say they use chain rule? I just go up. Do you use chain rule?
No.
Can we just do it normally? How would we?
How? Oh, yeah.
You got two X, right?
Mm-hmm. EYPX, right?
Let me see.
Oh, DXDT, is that what we're using? Oh, that's right, you're right.
Wait, what?
I feel you didn't really understand. Let's solve it together. This is the question, right?
Yeah.
And they're saying that y changes with respect to t and x changes with respect to t.
So you have to differentiate X and Y?
Anything that changes with respect to t, you differentiate it implicitly.
Mm-hmm.
So you
Oh.
differentiate the y and you have to differentiate x implicitly with respect to t.
Mm. So you have to add it.
Yeah, and they gave you the x dt. And they gave you x, so just plug them in and get a final answer.
Okay, now I get it now.
X equals 1.
X equals 1. What's
What's
the x?
It's 2.
It's 2?
Mm-hmm.
And you're solving for d by dt.
Yeah.
Equals 4. Okay.
Read this question.
Oh, now we have to do area of a circle.
Mm-hmm.
I know that one. A equals pi r squared. Or 2d times pi r squared. Wait! Okay, no, I know this one. Pre-calc.
You're done
With what?
reading it?
Mm-hmm.
Okay. So they want us to find the rates at which the area is disturbed by the water changing. So they basically want us to find the ADT.
Mm-hmm.
And we know area is equal to pi r squared. We know that as the area is changing, the radius is also changing, right?
Mm-hmm.
So let's first differentiate this implicitly. Let's differentiate it. What did you mean?
I didn't figure this out. What happens to a pi? Oh, do you keep it there?
Let's try using the formula.
Oh, it's multiplying.
The first one, you differentiate the
product
first
rule?
one, right? Yeah, the product rule. You differentiate the first one, right? And you get what? 0.
0.
times this is the same as 0. So you get 0 plus you differentiate the second one, which is what 2r.
We're using product rule?
Yeah, because they're multiplying.
Oh wait, yeah.
Okay, wait. So
No, I knew that. No, I
so
knew
wait, what rule did you use?
that. No rule. I wasn't thinking.
You
No,
just
I was-
guessed it.
I was using what's that called? Power. But I forgot about this constant. I forgot it's multiplying
Okay.
and not just
Is it 2 pi r?
You keep forgetting you're differentiating implicitly.
Oh.
Radius is also changing.
R T? Is it P R Z T?
Yeah.
okay.
Then plug in the values. You have the RDT. How did I know that this is the RDT? They said that
The radius is changing.
yeah, it's changing at this rate. So the RDT is what 1 foot per second. So if they had said it's decreasing, I would have made them negative.
Do it what?
I've made it negative. But since
Negative?
it's
Mean what negative?
This.
if they had said the radius is
Increasing?
decreasing by 1 foot per second, and maybe the RDT was negative 1
Okay, yeah.
because the rate is decreasing. But since it's increasing, it's positive. So I have this, you plug in your values, then you get
So
your final answer. Before we do proper questions, this is the general guidelines for solving these kinds of problems.
Huh?
I said before we do proper questions, all that we've been doing are like warm up.
No.
Wait, you didn't get something wrong.
I didn't see how they got that 8. I mean,
That's when you substitute.
yeah, I didn't read that.
So you understand now?
Mm-hmm.
You sure?
Yeah.
Okay. So
You're gonna mark off points if you don't write this one. The square feet.
Square feet per second? Yes, I think she said that.
Got it? I hate word problems. I already said words don't belong from math, so we no. Draw.
Impossible. It's not gonna be possible for me.
You need to draw it always.
Why?
Questions like this.
Oh,
It's better
the
you-
thing
you
that's
draw it.
what's his face do?
Questions like this, it's better you draw it.
Oh, but this is elementary.
She's definitely gonna tell me so you have to go on it.
Oh yeah, that's gonna be on it. That's gonna be on the back, actually. I see that as question 4.
So then, you don't need to know like any what's it called formula for this. For these ones like this, we have to draw. You don't need to know any formulas, right?
You need to know formula. Like, without a formula, how can you solve it?
Mm-hmm.
But the formula you normally know for these triangle
It's
problems are
hypotenuse.
Pythagorean
Yeah.
theorem and similar triangles. Some examples will need you to know similar triangles. I don't know if it's learned or it's not learned it.
No, it's recalc.
I don't know where you should learn it, but
Geometry.
Similar.
No, not
triangles.
No,
It's
you
like
don't
the-
do. You do learn like pre-cap.
Like if you have something like
But we
this,
never went
Like-
over it.
this inside
You
triangle
put the line in it.
and this outside triangle, they are
That's
similar.
geometry right there. But I know like.
Ew,
I know, like,
similar
this,
triangles, you meant like
like-
that. I thought, yeah, no, that's what I
And
meant,
then,
the
like-
30, 60, 90.
Yeah.
No, we're talking about two different things actually.
But, so you need to learn about Pythagorean theorems and the triangles for these kinds of problems. If it comes as a triangle, but some come as the conical flags as we first saw, and some also come in the form of like a spherical object is being inflated or deflated. Like, like I'm just telling you how these questions they normally come in the exams. But for now, we're working on triangles, so let's
Practice
read the
all,
question.
all the different ones.
Hmm?
We need to practice all the different ones that could show.
Of course.
I don't want the circle one to show up again.
Did you go to buy some madness?
What?
Did you go to buy some madness yesterday
No.
in Burr?
No.
I saw apparently Baby Chief Duo was there.
You heard the question?
He's like this dude that's been blown up. It's like this like kid.
Oh.
Like you ever seen the Boondocks?
No.
Oh. Well,
Yeah.
you ever seen this dude? Oh. Yeah, he was at the school. I didn't peep that till today, till just now. But he's blown up because like there's a Boondocks character named Riley that like acts and like he kind of acts like in a similar fashion. But then his music's also pretty hard too. But yeah, I didn't even peep.
EMP?
No, like I didn't even know that that he was there until I just resaw it. And then the band we played there ourselves like a little bit before practice. So we did like a whole little mini performance and then practice till like 11.
You're done reading the question?
Yeah, I don't know what you were doing though.
No. All that I'm waiting for you to do is to first read this.
Oh.
Then read that.
What'd you say? Just read it?
First read this. This is the general guidelines. How to solve it. After that, you read the question, then you solve it.
Okay.
You're done?
Yeah.
Okay. So basically, we have a ladder and it's leaning a wall like this. This is the wall. The vertical line.
Yeah, that's the fourth question.
You're done?
Definitely not. Solving it?
Of course not.
Oh, what did I say? It was supposed to be solving? I was drawing that. And the first step was read, then you draw.
So yeah, the first step is to draw. In questions like this, I'll advise you to draw it always. So
Yeah,
this
she's
is the
definitely gonna make it draw.
ladder, right?
Oh, don't.
Should I wait for her to continue?
Wait
Continue.
for who?
You.
Oh,
No,
me, no,
continue.
I was just wanting to do something right now.
Okay. So this is the ladder and this is the distance. This is the floor. Distance from the floor to the top of the ladder is this. And this is the distance from
edge of the ladder.
Yeah, this edge of the tip of the ladder touching the
To the
floor
wall.
to the wall.
Mhm.
And they're saying that the ladder is coming down, so this part is coming down, and as this is coming down, this part will be increasing. Like, try to picture it. Let's assume this is the ladder.
Mhm.
Let me put it like this, and it's coming down like this. You see that this distance
Moving
is
farther.
increasing
Mhm.
as this is decreasing, and they want us to find the rate at which this part is decreasing.
Okay.
That's the whole question.
So I was wondering, like, when X is 6,
This is what she was doing.
what is Y? Is that what they're asking?
Well,
When X is 6, what is Y?
that's the one they
The
asked.
rate of Y?
Exactly.
Okay.
The rate at which one is changing.
Okay.
So we have this. The first rule was what? With the problem from drawing, assign symbols to other quantities or functions of time. We've already done it in the we assign symbols.
What do you mean the sign symbols? Like Y and X?
Yeah, exactly. This is the most important thing. For now, you need to find a formula that relates them.
That's why there's Pythagorean theorem right here.
Yeah, you need to find a formula.
So if there's a triangle, you were talking.
Okay, you need to find a formula that relates them. Like, that's very important. That's why you need to memorize all those formulas off. Because those formulas are what will relate the
That's how you
values.
solve the problem.
Exactly.
Right. If you don't know that, then you can't solve the problem. Then that's
Exactly.
minus 25 points. Okay, wait, so for triangle problem, is it always gonna be like Pythagorean? I knew how to pronounce that.
No,
Theorem?
no always. Some also demand similar triangles. The knowledge of similar triangles. What else?
So no, but I think she's gonna go with this, right?
You never know.
I mean,
What is that?
Similar triangles.
similar triangle.
Is there like a formula?
Let's solve this first. After solving it, then we
Do you practice problem of it?
then we run through similar triangles.
Okay.
It's easy. It's not hard. So this one we know that x squared plus y squared equals 10. Yeah, let's get plus b squared plus c squared. So x squared plus y squared equals to 10.
They put 10 squared.
I mean 10 squared, sorry.
How did they know that was C because of this?
Oh, wait. They gave you the information you needed. This is the length of the ladder. Assuming this is the ladder.
Hypothesis.
Yeah,
Oh yes.
that's the hypotenuse.
Oh yes. Oh, we knew that.
So you agree up to this part?
Mm-hmm.
Then let's differentiate implicitly. Like, let's differentiate by any value that changes with respect to time, with respect to time, differentiate implicitly. And wait, this one, we know that this part changes, right? And I know this part changes, right?
Mm-hmm.
And this part also changes.
Mm-hmm.
So we differentiate them implicitly.
Both of them.
Yeah. So let's solve it.
Equals 0, right? No, like we couldn't even have this.
Exactly. You're done?
Oh, okay.
Differentiate.
Okay, I see what you
everyone
mean.
and then just add the in respect to time. How do you know it's in respect to time? Is that what you're trying to find?
It says it up there. Both functions keep.
No, this is part of the solution.
Yeah, they
Oh,
don't give us
you're
that.
right,
All
you're
we're
right.
gonna see is this.
But this is it. They told you that the rate at which wait, if the bottom of the ladder slides away, so this distance keep changing because this slides away, it's like this, and keeps sliding away. So the distance changes with respect to time. And they even gave you that the rate at which it changes is 1 feet per second. So every second it's increasing by 1 feet.
Okay, that makes sense.
And if you've been solving these kinds of problems, even if they don't say this part changes, you know that if the ladder is there and this changes, then definitely the height will be changing. Yeah. So that's how we know they change with respect to time. So after getting to s dx over dt plus 2y dy over dt equals to 0, in fact, what do they want us to find? The rate at which the y is changing. So let's try to make that a subject.
Oh, get it by itself.
Yeah.
This is wrong.
You're done?
How did you do it?
How do you do it?
Let's do it together.
Okay.
2x dx dt plus 2y dy equals 0.
You subtract this one. Oh wait, no, this is already on this side. Wait, don't worry, don't worry. I'm speaking myself.
Why did you clean it?
What do you say?
I said why did you clean it? You're on the
You
right
have to
track.
subtract negative 2.
Yeah,
right?
no,
Yeah.
no, I just have to realize that again. No, I did that.
So after subtracting negative 2y dy it's on the
How
side
do you
out
do
there.
Then you divide by
Do you
negative
agree up to
2y.
this point?
So,
Oh, I mean, I should do it the other way now.
Wait, I did it that way.
That will also work, but
Wait, but now I'm confused.
because we're trying to solve dy dt, right?
yeah, so let's try to make the one dt.
Oh, is
here.
that why I'm looking confused? Because I didn't think that way. You guys subtracted dy dt?
No, subtract ds dt.
Yeah,
Wait,
that's
you
what
do
I
it
did.
that way?
Well, it
Do
doesn't.
it that
It's
way?
the same thing.
It's the same thing, but
I just did it like that because
this
usually
the
it's like on the right
conventional
side.
yeah.
Yeah, I mean on the left side of the.
Yeah.
You know what I mean? Like, because we're solving for this.
Yeah. So this is it. Do you agree up to this point?
Yes,
Then you divide it by 2y.
that's what I did. How do you get rid of the dx dt? Can you not? Oh, you plug it in.
Yes.
Oh shoot. I would be stuck. What is it, 1?
I got this. Do you agree? You don't?
What is that?
Yeah, you just divide it by 2.
divided by 2.
Then you cancel 2 cancels out. Then get negative x over negative y ds dt.
Yeah.
Yes, over dt.
Over y? Over y, right?
Yeah, negative x over y.
Yeah. dx dt.
Oh.
Yeah.
Like this, right? Or
Yeah.
did you just write it different?
Yeah, I just brought.
You just wrote x like this. You wrote x.
Yeah, it's the same thing.
Wait, row x like what? Oh.
Yeah, it's the same thing.
I don't remember that.
Now, after doing this part, what do? We check. I mean, we want to find the y dt, right? So we check if we can plug in values for all of these. So we need a value for x.
That's 6.
That's 6. We need a value for the x, the t.
Mhm.
That's 1.
Mhm.
We need a value for y.
They gave us 1?
That
Oh, we have to find it.
Pythagorean theorem. We know that x is 6. Hypotenuse is 10. What is y? 100 minus 36 square root of that.
Oh, so we go back into the original equation.
Yeah.
Wait, x is 6?
Yes. All the way at the end of the hall.
Let me see. Have y'all seen Dr. Drew Dickinson? Is that his name?
Yeah.
I don't know. Oh, Macy. Dr. Macy Dickinson.
This is what I was doing. You got.
And once you get y, do you just go back into the whole equation and plug everything in?
Yeah.
Yeah.
Like
This test corrections.
yeah.
Like scan it
You have to, and I
into a
love.
PDF file. Send it to them.
Okay.
Send it to them as soon as possible because you don't want it to. You'd be like, oh, it's late.
Yeah.
I would just scan it from Adobe or like Notes and send it and CC me.
Okay.
Yes.
Alright. Thank
Tell
you.
them that I told you to do that.
Okay. Alright.
All right.
Thank you.
See you.
What answer did you get?
I do 3/4.
-4. Okay. That's right. Did you get some Alana? Oh. You all don't be forgetting to be bringing the units, okay?
What'd you say?
Huh?
The units.
Oh, shoot. Yeah, she definitely marking that off. -1, just like 3 times 2.
Can you explain to me why it's negative?
Why is it negative? Because
Mhm.
x is negative.
Because
It's the y.
Oh, because it's decreasing.
The change
And it
is-
decreases as it
yes.
slides out. There we go.
It's because it's sliding down.
exactly.
Because x is negative. Right.
Not you.
I mean that's technically true because there's negative in the equation.
We went in the real sense.
You're my fault. We're done with this one?
Yeah, we're done with this question.
We've got like 40 more minutes.
Great time.
Wait, when do you wanna go?
We're gonna be at like 12.
What do you mean we not?
Because when you leave.
When I leave,
I only got 12, don't you?
I leave about 11:30.
Oh, you
Oh,
leave early?
really?
I'm kidding. I leave on 1.
Oh, do
Do you actually leave at 1?
Oh, no, yeah, last time because we were in here doing our math class, remember? And they
Oh,
were
you're
still
right.
in here.
I leave on 1.
Got math class at 12.
And you're not allowed to be listening to it?
No.
Should we move forward or should we
You
do the
tell me
similar
like what
triangles?
happens.
Can we, huh? What'd you say?
Should we do the similar triangles or should we move forward and
I
solve
think we should
question
practice one more question on this.
on this?
Because, wait, what do you mean move forward? Move forward in what sense?
I don't think
Solve
she's
this
gonna put, you
question.
think she's gonna put similar triangle on there?
I mean, it's
No,
for
I don't
if
think
she
she's
brings it.
talking about
She hasn't talked about
fair
it.
if she brings it.
So I don't think she will.
Can we, okay,
Can
can
we
you
do
do it
another-
really quick and then let's solve that? That's another practice problem. Like, we should just do all
A
types,
sphere.
so we know.
Of the, each of the shapes, so we're not moving it. So fun.
Sunday, I don't wanna, I can't learn
Oh,
all
yeah,
this on
I'm
Sunday.
so sorry. Yeah, what are you doing on Friday? Oh, shoot. And,
Check.
and the sun sets.
These are 2 triangles,
When the
right?
sun goes down.
Sorry.
These
Yeah.
are 2 triangles, right?
Uh-huh.
This is the outer one and this is
Mm-hmm.
Oh, I think I know what. Never mind.
They're both right triangles?
Wait, the
this,
audacity.
this looks a little odd. What do you mean that's right triangle? That's not no right triangle.
It's a right triangle.
It is?
Yeah.
Oh, it's just the
a
way
bit
you.
weird.
Oh, my fault, my fault. Let me stop making fun of your drawing.
Is this better?
Yes.
So basically, in similar triangles, all that we want to say is that the ratio of the corresponding lines
Oh,
should be
okay,
the
I
same.
get what you're talking about.
Oh, wait. I know stuff.
I know this.
Exactly.
Right?
So how would that question look like though?
I honestly cannot form a question about that now, but if you see a question and it's triangle question and you cannot use Pythagorean, think of similar triangles.
Think of what?
Similar triangles.
Okay.
So basically, assuming this part is A and this part is B, the ratio of A over B should be the same as, let's assume this is X and everything here, X, Y, should be the same as Y over X. You look confused.
No, I am.
Hold on a second.
I am.
This whole bottom is y.
Mm-hmm.
It should be the same as y over x. Oh, are you saying that this whole thing is a, and then this is like half of a?
Not necessarily half. but
Like, you
this
know,
is
it's
B.
part of a.
Yeah.
And like you're saying
No,
how
no,
x.
no. It's not necessarily.
No,
this-
you mean it's lining up with the big A.
Oh yeah, yeah.
This
of course,
part is
of
like,
course.
but it's like kind of like lining up. So you're
Mhm.
saying in the same sense that x is kind of like lining up with y.
Exactly.
Oh, okay. Because I thought that the way you were gonna do it is like a, and this is like x, and this is like y, and you were like, yeah, you know.
I
That's
mean,
still same. That's still like same thing.
I can also make just this part y
Yeah.
and make this x plus y over x.
I'm sorry. What?
Assuming I said nothing just now, I don't wanna confuse you. So like what I said first. I know Amanda is confused, but I'll come to her. This is it. A over B is equal to y over x. Does this make sense?
Yeah.
Makes sense. Can you explain to Anila?
Okay. See. Okay. So there's two triangles.
Yeah, I can see.
A, like the part of A is a part of the big triangle. Like let's just focus on the outside, the big triangle first. So,
Can you turn your things off?
oh, I'm so sorry. They're gonna get silenced.
Sorry. it's
I have to
distracting
silence
me.
them sometimes. Okay. Okay, so big triangle first. This whole thing is a big triangle, right?
Mhm.
Okay, let me erase this triangle key. Hold on. Or let me retry it, cause okay, let's think about it this way.
Regular, right? No, not regular.
Don't pay attention to the right angle. It doesn't.
No, okay, no, I know it's the right angle now.
Okay, so this side length right here, that whole thing is A, and then in the smaller triangle, this is a different triangle, right?
Yeah.
It's a smaller one. This side length is B. Do you see how like, I know it's not necessarily half, but how half of A is B?
Mm-hmm.
So, stop! I said it's not necessarily half, but for explanation's sake.
It's
You
not
get
half.
it.
Okay,
Get
yeah,
it?
yeah, yeah.
She,
Go,
it's
go.
cause that's how she's gonna understand it.
If
It's
you
not
say it's
half, like it's part. It's like
yeah,
not.
it's
okay.
part.
It's a little
Use
bit.
that.
Yeah, of
Of A.
of the whole triangle.
Yeah. Okay, so that relationship is like A over B, right? Okay. And now he's saying this whole thing, this whole side right here is Y. That whole side, this whole
Why are you
thing.
saying why? Can we see?
Okay. That whole thing is C.
Okay.
Okay? And now he's saying For this one, this individual triangle right here, that's D.
Okay.
That one is D, right? So now this relationship is gonna
They
be
equal each other?
Yeah, it's like C over D.
Yeah, and they
C
equal each
over
other?
C over D.
Am I confusing you? Just write X, Y. It's the
It's
same
D
thing.
over C.
Why is it X?
Wait, which one did we say was C? Oh, never mind. I was right. It's C over D. The big one over the small one.
A, B, C, D.
Do you understand?
Yeah.
You sure?
And you
Yeah.
see how are we lying?
No, I'm being for real.
Okay,
You just explained it.
You're done.
Yeah, I see. So what is the relationship? They equal? They should be the same?
Which should be the same. Wait, that's the relationship, right? They equal each other, yeah.
Yeah.
I knew that.
I knew that too. I don't know where he's coming from.
So assuming you have A, B, C, D.
E.
So assuming this is E and this part is F, it's the same as E over F. Yeah, so like having this in mind, it will help you solve some of the question.
What letters would you have used next to explain that? What letters would you have put there instead of A, B, C, D, E, F?
He was just in
Because you did,
random
you did,
letters.
oh, because you did A, B, X, Y.
Oh, maybe I might.
Sorry, that's what confused me.
C, F, A,
T F.
T, F? Oh yeah, you would thought we lost there.
You know she doesn't like letters. You know she doesn't like letters.
Can you solve this by yourself?
By myself?
But don't
No,
look
don't look
at
at
the
the-
question,
yeah,
the
don't look at
solution.
the-
But just know that
But
the
solution's
formula
right in front of
for volume is
you. We
4
know
over
that.
3
We know
pi.
that.
Is what?
4 over 3 pi r cubed.
We know that? Whoa.
Before we did. Wait, just scroll up a little bit. So I don't.
Wait, what is it again?
No, check hers.
No, I'm gonna scroll up, but like, what is the, what did you just say?
You see, yours is small. Why don't you just
Oh.
go into the whole thing? Just don't do that.
No, just scroll down. Can you not see?
What are you talking about?
Don't look at the solution.
Yeah, but what do you just zoom all the way in actually. And go down. It's not that one. Maybe it's that one.
No,
Go
we're on
down.
this one.
No,
Oh,
we're not.
my fault.
Yeah.
It's that.
But first of all,
Wait, we're not.
can you scroll down? Wait.
I'm zooming out.
So I can see the whole cost there.
You're not. You're supposed to see just the example.
Just
Yeah, we
copy
can't see the
this.
solution.
Like
Oh.
another volume after that you try solving it.
You can't see the thing that says solution either.
Exactly. No, that's why I scrolled up so you only see that.
I don't like that.
Too bad. You have to like it. Let's read. Let's see. Air is being pumped into a spherical a sphere. What's a sphere?
Oh, I don't even know what a sphere is. I was just thinking a balloon.
Oh. That's what a sphere is a circle, right?
No.
What's a sphere?
No.
How does it look again?
Like oval?
Words different.
How do we not know how a sphere looks?
He doesn't know
Yeah.
what a sphere looks like either. What?
I know, but I'm thinking of how to give you an example.
Just draw.
I cannot draw a 3D figure.
No, just like a very simple.
Oh,
No.
I know what it is.
It looks like a circle,
It's
but
like-
if I draw this a circle, this not a sphere. It's 3D.
Obviously, I know what that is.
But I
Figure
don't
out
know
a
how to
circle.
draw a 3D figure.
You don't
She's
have
not gonna get
You
a
don't have
3D
to
figure.
draw. You don't have to draw this.
It's just a diagram.
Do you have to draw this? You don't
Oh,
have to. You
I-
only draw the triangles, right?
Okay.
Wait, when did we say we only draw the triangle?
She's not gonna make you draw a sphere.
The second step is to draw a diagram.
For the ones with the ladder.
Oh,
It's
sorry.
okay, wait.
She said if possible.
Right?
You definitely don't need to draw a sphere.
My father's calling me.
You definitely
Yeah, cause who's gonna sit there?
Hello?
I'm not sitting there drawing spheres. Cause
Okay.
I don't know how to draw that.
We're in tutoring. Huh? We're in tutoring. We're in tutoring. 12. 12. No, I already have a Kyla.
Hi.
He's not paying attention.
Hey. I'm doing good. How are you?
So you're not drawing the spear?
No, you don't have to.
You don't have to.
Yeah. No. No, no. Like, who is that? So the volume increases. How fast is the biggest diameter? Oh, no.
What question did I give you? This question, right? Anything comments with
If I say the constant, you have to write anything, right?
Zero.
So we get you're done.
Wait.
I didn't finish.
You go on.
Did I do something wrong?
Let's solve it together.
Did I do something wrong?
Let's solve it together.
Are we not supposed to multiply these two?
Let's solve it
I don't
together.
know. Okay, okay. I hate word problems.
You shouldn't hate it.
Why? Not.
It's so coming out. Okay. As we're solving it together, if I reach a point where you think you can continue from there, you can tell me to stop there, continue.
Mm-hmm.
So they want us to find how fast the radius of the balloon is increasing. So they basically want us to find what the arrow, the T, right? Right.
What is diameter?
It's
Is that the radius?
no.
No, 2 times the radius.
So I have to know that too?
Yeah.
Okay.
So they want us to find this, right?
So if you divide this, then you sorry.
They want us to find this, right?
Mm-hmm.
And
dr dt?
yeah,
Wait, what's this? Oh no, we're solving this. Sorry.
yeah. But they first of all, let's write all the things that change with respect to time. Radius changes with respect to time, right? And what again? Volume. And what again?
Diameter?
That's true.
Am I wrong?
You're right. But it's related to radius, so it's basically the same as radius
Yeah.
changing.
Okay.
So these 3 changes with respect to time, but we can relate 2R equals to D. So we just take one of these. And let's find an equation that relates them. We've already found one.
Mm-hmm.
Let's find another one, which is volume is equal to 4/3 pi r cubed. This is the volume of a sphere.
Mm-hmm.
And it's relating these two things that changes with respect to our time. So all that we have to do is simply differentiate implicitly.
Mm-hmm.
So can you help me with the answer?
You want us to give it to you?
Yeah.
3r squared. Oh, okay. Oh, first one. You want to do the first step?
Yeah,
So
like
0 times
step by step.
0.
Wait. How do you?
Differentiate for 3 pi, right?
I want you to start from the V, the T.
Oh,
because
sorry.
that part is really important.
Oh, okay. Oh, sorry. I forgot about that.
The,
It's on my paper, but
yeah. The V, the T
equals
equals
0 times r cubed plus 3r squared.
3R squared.
You know what I mean?
That's what.
No,
That's what.
dr dt times 4/3 pi. 4 pi.
Wait, you got 3R squared. I
Is
get
that
it.
wrong?
No, it's not wrong.
I just wrote 4 pi r squared.
That's easier.
Okay. That's right.
What happened to the 3r squared?
I simplified it. You're right. You're right, but I just simplified it.
Yeah.
Both of you are right. Wait.
Oh, dr
Yeah.
dt.
So this 3 cancels this 3.
Oh.
And we get 4 pi r squared.
Dr dt.
Yeah. Since they won't
4
be.
pi r squared times divided by 3 still, right? Wait, what?
No, think about it like this. We could.
Oh, it's just 4 pi r squared.
Yeah.
Okay. Mm-hmm.
Yeah.
And then we're trying to find dr dt.
Yeah, so let's make it stand long. Whenever we reach a part where you think you can continue, I don't know.
We just divide by 4 pi r squared. No, r squared.
You can't divide by it?
Oh, okay.
I should already solve it. Oh no.
No.
Basic mathematics. Okay.
You divide?
Yeah, when you divide, because that multiply.
Okay, yeah, that's fine.
I was thinking there are there.
So is this the volume?
Yeah.
Did you
You
just
said yeah.
No, this is the rate at which the volume is changing.
So
You just
we don't need to use this,
massify?
right?
So, wait, that's the rate at which the volume is changing. So it's what the V dt.
Oh, okay, so 3.
Did you just do a mass divided by 4 pi r squared?
Mm-hmm.
Did you just? Okay. Oh well, I guess
Oh,
you did it like that.
And I think with the rest you can plug things in.
Okay.
You can plug the V dt in,
Can I go up?
and you can plug R in.
This
Your radius
Volume
is
is
half of
100.
diameter.
CM squared. Wait, okay, dv dt would be plug in 100 for that one?
Mhm.
Oh yeah, wait! Okay. So 100.
After 52.
Let me start putting the root into this section. Square
to solve this with no calculator?
Yeah.
She's pretty.
25 pi.
What did you say? Oh,
Oh. What are you plugging for radius?
Yo, I got one question for you.
Okay.
Nah, it's brief.
Okay.
It's brief. So like, we've been doing like polar coordinates and stuff like that. You know, in the past, like, I've been like just been trying to like memorize like the radians.
But it's r squared, so 25.
Whenever you're trying to find our
So 100 divided by 4.
whenever we are
So it's 120.
looking for our reference angle, like I'll just try to
125.
Huh?
memorize the radian because we don't have a calculator and like one of
We
the
got 125.
1 over 25 pi?
Mm-hmm.
How?
25.
the YouTube videos, they told me like to use like arctan and stuff like that, but like we don't have a calculator, so
Okay.
I can't use that. So I've been memorizing. But I heard there's a way that you can use you can use the 30, 60, 90 triangles and stuff like that to be able to like
To memorize like the radian.
yeah, so like
How happened to the square?
like your pi over 3 and your pi over 2 and stuff like that with the 30, 60, 90 triangles.
Wait,
Wait.
probably, wait. Let's
And,
get
and,
this.
and then I asked this.
Like how?
100 over
Oh, because we're
4
Do you mean like how you
25
have
square pi.
sine 45? That's like root 2 over 2.
Yeah.
Oh, because you square.
Yeah,
We're
yeah,
just trying to find the radius.
yeah,
You
yeah.
don't square it.
Oh, okay, okay.
Nah.
Is there like a shorthand for that? Like, do you know?
Oh,
of?
it's not
I
square.
don't know.
Wait,
I had to
wait.
memorize all of
Is
it.
this why you
Oh,
get from
so well, there's okay.
What's that?
But I know like
But,
when
like-
we're talking about this like triangle.
Yeah. And then so when you do that, are you doing like?
Did that.
So 4
One
goes
over
into
25.
I think I asked it at some
125
point. But when you do, are you
So you get 25 over 25.
like if you were to draw the circle out, are you doing like
And this
which
becomes
side?
1 over
Like you said, sine
Sine 45
sine 45 is pi over 2, right?
is root 2 over 2.
So I get
Or
25
or square root of 2 over 2.
And this would be
Yeah.
1 over
So sine 45 square root of 2 over 2. Is there a way to like? Oh wait, because it's sine, that's opposite
Yeah.
over hypotenuse. So that's
1 over 25.
across
Yeah.
from the angle. So it'll be 45 degrees. So this is your
That's the
triangle.
way they were doing it.
45 is
I
right
think
here.
this is the answer.
Right here would
The
be
way we were doing it works.
I don't have
square root of pi over 2.
No, I don't.
Yeah.
Okay.
Yeah.
Okay. Yeah. No, I understand that now.
Okay.
Okay. Well, bet. Yeah, that was it. That's all I had to ask for real.
Then
You hate it?
Yeah.
Let me
I've heard that a question like this will come in your exam, but this is like one of the easiest kinds. If you get something like this, I've not read the question, but immediately I looked at
Oh.
it, I realized
Is
it's
this
not
a
easy.
Triangle
Oh,
thing.
she's putting.
Yeah,
Oh, what?
okay, I know like
I've
to
not read the
get
question yet, but immediately I looked at it, I knew that it wouldn't be straightforward. Looking at all these.
to get
things.
like
Tan.
some other angles.
So, but normally they don't give questions
Yeah.
like this in exam.
For the sine and the cosine,
Mm.
like the graphs also help.
That's gonna be the first question.
So like for the sine graph,
That's gonna be the first
No,
question.
we don't need to.
If y'all need me, I'm in the next class already.
I
Okay,
think
sure.
we should just practice the other one.
the
Normally
sine graph
they
is
don't
something like
give
this.
questions like this. in
We don't have enough time.
It starts from the origin.
I've not read the question, but
And
I
goes like
feel it
this.
might take a long time.
Okay,
but-
then the 6 on
but
time, so
they
that's not
give-
gonna be.
We can read
Right,
the
right,
other one.
uh-huh.
But they give easy questions
Yeah,
like
here,
this, where
zero.
like you just follow the normal formula. Find the equation that relates, then differentiate in places.
Pi
don't
over
plug
2.
this in. If you don't know a value, think of another formula, like the diameter is 2r
Pi.
equals to d. The other one is Pythagorean theorem to find
3 pi
y.
over
Like,
2.
they are easy and straightforward.
2 pi.
Yeah. Do you want to solve this? It's not hard.
She loves that. She loves showing away quotes inside.
This is similar to the question we solved. This is similar to the question we solved, but now you see,
Oh, is it lateral?
yeah, check this. we have this angle, right?
Mm-hmm. That
And
was
they-
just a ladder.
So looking
and
at
they
this, I
wanna
could say
check
like
the rate at which this
um,
angle
when sine is pi over 2 is also
because
equivalent
as
to
it
1.
slides down, the
What did you say?
angle what
Like so, like based off this, I would say like if like if sine
It's pi over 2, yeah.
yeah, or sine's 3 pi over 2, then it's
This is the
equivalent
house
to
on the
negative
left.
1.
Yeah,
This
so
is the
sine
ladder.
pi over 2,
exactly.
And then
which is the same thing
it
as
starts to
sine
slide
90
away.
degrees. That's
And we're
equal
trying to
to,
find at what
1.
rate is angled to
because
the
you know how
ladder, so
pi
this
is
part
like
right here,
180.
rubbing,
Yeah.
So,
changing.
yeah.
When the
And
base,
sine
so
pi
this, the base is
would
like
always
right
be
here.
0.
Base,
He said it starts talking about the base.
Sine 3 pi
the
over
base
2
of the ladder, this the
would always be
base.
negative 1. And
Wait,
sine
but
2
then
pi,
what rate is angled to the ladder
0.
and ground change?
What about the 3069 one?
That's
The other one.
sine 30
This is the ladder.
is
Can
1
you
over
see
2.
Yeah, I can see.
Yeah, this
Sine
is the
60
ladder. This is
is
the angle between the ladder and the floor.
Mhm.
As it slides
Root
up,
3 over 2.
the angle changes.
Mhm.
And they want to find the rate at which that angle is
Yeah.
changing.
Oh, okay.
No.
like
That's
over
the other
time.
question.
Yeah, I just gotta memorize it.
I had to memorize it, and like I realized like there was a pattern because
The first
sine
step,
30 was 1 over 2, and cos 60
find an,
was 1 over 2,
an equation that relates
and
them.
cos 30
And this is the equation they follow.
was
Cos theta
root 3 over
equal
2.
to x over.
Oh, that's the one he did.
So cos 30 root 3 over
This
2,
is what
sine
we did.
60 root 3 over 2, sine 30 1 over 2, so cos 60 1 over 2.
Easy,
Oh, okay.
And I noticed
right? This is
Okay, so now we need to
cos
draw it.
45
Yeah, questions like this, it's better you draw it.
was root 2 over
And I
2,
mean, if you don't draw it and you say
And
x
sine
and y, the
45
teacher wouldn't know what to mean by
was
x.
also root 2 over
The
2.
base of the ladder starts
we
to
have to draw like that.
Mm.
10 feet ladder.
2. And cosines also.
Between the ladder and the ground.
2.
Oh, you looking at it?
Yeah, looks like memorizing
No,
is
not
the
the
best
not
way.
Oh, no, no,
What?
no.
I say, yeah, looks like memorizing really
You
is
can
the
look at
best
the
way.
solution, like,
Mhm.
When the base is
if you don't understand the solution,
And-
let me know.
Mm-hmm.
So kind
You
of
should always
like
remember
this.
that sine x
I
over
want us
cos
to work
x is
linear
equal to
approximation.
What's
tan
what's
tan
that?
x,
Yeah,
That's
of course.
still 3.9?
No, that's
which means that tan 45
Oh, okay. If anything, Tolu can teach it to us.
Is
'cause we
1.
don't have time.
What's the time?
What time is it?
It's 11:44.
Oh, okay.
Yeah, because they're the
And
same.
maybe we can
Okay.
start, and maybe we can
and
finish it.
tan 30
Is it like law?
and tan 60.
Linear approximation is really easy. It's easier.
I always mix up tan 30 and 60, but we can confirm that with Gemini. I think it's 1 over root 3,
What does y
and
come
tan 60 should be root 3. We can confirm these two.
Which one?
Gemini.
Why is that right here?
Why's y?
Thanks.
No, they mean, I think the one
The
stands
side is
for
Y,
this.
right? The wall?
Yeah, the one.
That's what it's been.
Okay,
Better
thought
be.
so. They're not trying to change that.
And they're
this
trying to
is
find this
they're
angle.
finding-
Yeah, the rate at which that angle
Wait,
is
where's the
changing.
10? The 10 is what?
The
Oh,
length of the ladder.
leaves 10 feet.
That's the hypotenuse. So,
So, opposite of hypotenuse? I know,
opposite.
you know, so,
That's exactly what I wrote.
so, uh, so hypotenuse over adjacent? Hold on now, no. Where's the x? Is the x, wait, what's the x? X is over
We're
there.
trying to find what angle between the ladder and the ground.
Close up the angle.
We're trying to find this angle?
Not that angle, the
Where
rate
did I
at
get
which
eight
that
from?
angle is changing.
Oh, x is 8. Oh, wait, no, I was, okay. Wait,
See, when these
we're trying to
problems-
find the D.
Should we?
DT.
Let's solve it together.
It's just reading the problems is throwing me off. Like, how do you know?
That's gonna take me
How-
about 15 minutes.
Exactly. How
So-
do you know when to, like, how do you know what you're finding?
Okay. Let's read that problem together. A ladder is 10 feet long, and it means against the house. So this is the house.
Mhm.
And the floor, so it lays like this. And the ladder itself is 10 feet long. The house is to the left of the ladder, so it's to the left here. And there's the ladder. The base of the ladder, this base, starts to slide away from the house, so it moves away like this.
Mhm. Like the one we just did.
Yeah. And the rate at which it moves is that every 1 second it moves away from the house 2 feet.
Mhm.
So basically, if this is x, the t is what, 2 feet per second. The rate at which this distance, this x is changing with respect to time is 2 feet per second. At what angle, at what rate is the angle between the ladder and the ground changing? So the angle between the ladder and the ground changes as it slides away.
Mhm.
And the one has to find the rate at which it is changing. When the base is 8 feet from the house, this base is 8 feet, so x is equal to 8. Do you understand the problem?
Yeah. Sorry, some like. Yeah.
Yeah. So one of the most important things is to find an equation that relates the things that changes with time. In this
Mhm.
question, y changes with time, right? X changes with time, and theta changes with time.
Mhm.
So they found this equation cos theta relating x and time. So you differentiate this time, and everything that changes with time you differentiate implicitly. So
I'm just confused on how they got the equation.
Me too.
on how they got the equation.
That's what you were just explaining, though, right?
Yeah, for the equation you need to think of, it's like you're solving a math question and like you're thinking of how to solve it, so you can come up with different equations. So I think they could have even done
Oh, can you know how cos is always like the x-axis? Like when you know cos is always the x-axis?
oh
And
yeah,
then it's always like x over like the hypotenuse?
yeah,
Can I think of it like that?
that is it.
Oh, okay.
So like I mean, if you want to start from SOHCAHTOA, it's fine. And this is cos, right? Cos theta equals to adjacent, which is x over hypotenuse. This is what that they did
That's what
here.
that is.
Yeah. So you differentiate this thing, and cos theta, you know that is what chain rule. So you differentiate the cos theta, where we get negative sin theta, then you differentiate to u, which is theta. And
Do we think of?
yeah, when you differentiate theta, you basically get 1.
Oh, you get one, okay.
Yeah, but
But it's implicit, right?
it's implicit because it's changing with respect to time.
Mhm.
So you get the t over the theta over the t.
Mhm.
And this one you differentiate x over 10. You can use the quotient rule since it's over something, or you can make it x times 10 raised to the power negative 1 and use the product rule.
I think I would like that better. Wait, do you say power rule? Never mind, we're using that quotient rule.
Yeah, I'm using the quotient rule.
Yeah.
Power is gonna confuse me. Yeah.
So you think
Makes
it's easier to use the quotient rule? X over 10 and get 100, 10 squared. Okay,
10 squared. Where do you get 10 squared?
that's the quotient rule.
Hold on now.
Oh yeah, it is. Cause you have to do a.
Okay,
Oh,
simply try differentiating x over 10 by yourself.
Okay.
Remember you differentiate x implicitly because it changes with respect to time.
right?
Is it, huh?
Yes. Is that what you call it?
Yeah.
You go 1/10 the SDT.
Mm-hmm.
Both of you.
Yeah.
You sure you didn't copy this straight away?
Yeah.
No. Yeah.
You said yeah. You said
No,
yes.
no,
Oh,
I'm
I didn't
sure.
mean I said
No,
like,
I
yeah,
said no.
sure.
I didn't copy that.
You didn't copy that. You
We
said
did.
Yes,
We
yes.
did.
Look.
We did. What's the
And
copy?
you said yes. You did copy that.
No, I didn't copy it. I did it.
Oh.
It's right there. You know
So-
this.
So you have this, and what do they want us to find?
The change
The change
in the angle.
of the angle. So we make that the subject. I mean, they all follow the same steps. Like
You're always trying to you always make an equation, and
Yeah.
it's gonna be what you're looking for is gonna be in the equation, but you have to get it by itself,
yeah,
and then you plug in something to
exactly.
get it.
Okay.
So if we're not doing that,
And when you
We're doing wrong.
and when you get to a situation where maybe you cannot find the x over the t, maybe they didn't give it to you in the question or something like that. Think of another. Think of another
What do you mean they're
equation.
not gonna give it to us?
no, if they don't give it to us, I'm losing
I'm
that.
not doing that
15
for-
points. I'm losing that
Okay,
15 points
okay.
for reading.
Okay, maybe they gave you the x, the t, but maybe they didn't give you x or y or something. I'm trying to say like for the
You
other
have to
question, they
find-
gave us diameter, they didn't
Yeah,
give
they
us
didn't give us
radius.
what
Yeah.
we need.
So think of another
Another
equation that will help you solve it. That's what I'm trying to say. Not making anything complex.
No, but if I have to think of another equation, then she's being left incomplete.
No, yeah.
Like, I'm sorry, this is one problem. There's
What do you mean you want me to find
more.
three different
There's
equations
more
just to
problems
solve
on that.
one?
Yes,
Right.
I'm not about to just do one question.
I'm been
Other
thinking.
things left
I've been
with?
thinking about that
No.
equation for like that's minus 5 minutes.
That's what we've been doing. We get focused in on
Don't get me
like
started on
the
those.
first problem.
question,
She makes the first one purposely complicated.
she makes the first one
And we
something
get
that we
focused
never
in
went-
on it and we lose 30 minutes.
30 minutes?
Okay, exaggeration.
She's
We lose
exaggerating,
like
but-
15 minutes.
That's still a lot. Like,
And we lose 15 minutes and then we have to rush with the stuff we do know
yeah.
and then we mess it up. So if this is gonna be like this,
I
no.
mean, if you can solve a question within 2 to 3 minutes, you should know. Like, I can solve it, I can solve it. If you
3
can't.
minutes?
We can't solve any of these in 3 minutes. Anything without moving just
No. I'm not saying you should solve the question in 3 minutes. Like, if you read the question and you can solve it, you know.
Mhm.
So if you think you can solve it, just
Just
move on
wait.
to the other
Do you
question.
think it's best when you're taking tests to do the things that you know first? And then
Okay,
get the
so you
outcome?
get all the points. Get all the points on what you know.
No,
Yeah,
get the
exactly.
for sure points. Because we
Exactly.
haven't been doing that.
No.
We have not. And that's why we've been bad.
I've been
on
trying to go in
tests.
order.
Yeah, no,
And then when
not
I
anymore.
definitely don't know how to do it, then I skip it.
Yeah,
Yeah,
no, 'cause
same.
I get in it and I'm like looking at the problem for 20 minutes. I'm like, oh shoot.
That's too much.
Well, now I know. We don't do that.
So
We
basically,
skip all the first problem.
You
That's not
make-
CB.
this one the subject. Right. You have time for class?
Class starts at 12:10. Ooh, I'm supposed to be meeting my friend at 12. Oh, never mind. Oh, that's okay.
What do you mean, never mind?
I'll probably meet her at 12:10. Let me know what's said today.
Should I stay in here?
If you want,
Or should I go back to my dorm? I think I'll go back.
and go back so you can get annex later. Oh, can we meet up at 4? Did you come?
Yeah, 'cause I have to go to the office and do shower.
I need to take my nap. I'm not
You're
gonna
done?
function.
So we're packing up?
Let's try finishing this question.
Oh yeah, you're right. Okay,
So-
we got.
We have this, and what values did they give us in the question?
Can you go up?
So we can plug, check this out.
Oh.
They gave us. Oh, they didn't say that.
Why?
Did they give us one?
Wait, no, I'm lying. This the-
DXDT and they
that's
give
the
us
XDT.
the hypotenuse and they give us
They gave us
Eight.
the
the
x.
X equals
They give us
eight.
X.
They gave us x, the x, the t.
Mm-hmm.
Okay, but we can plug in the x, the t here, right?
And that's 2.
That's 2.
Yeah.
Okay. We can plug in the x to t here, but we don't know sine theta. In fact, we don't know theta, so we don't know sine theta. But we know that sine theta is equal to what? Y over 10.
Yes, we do know that. Oh.
Yeah.
Okay.
Cause SOHCO.
Exactly.
So I was. You think of that? I think of pre-calc.
So
That is pre-calc. SOHCO is pre-calc. I learned that.
Different.
Oh, I learned that in pre-calc.
So sine theta equals y over 10. We know x, right?
You said what?
I'm sorry.
We're running out of
I
time.
really want us to finish
I'm
this
so
before
sorry.
we
No,
go.
keep going.
Like they keep interrupting me
Sorry.
with conversations I don't hear. So we have this sine theta equals to y over 10. Agreed.
Yes.
They still didn't give us y. Neither did they give us theta nor sine. I mean, not sine. Neither did they give us theta. So, but they gave us x. So during the examination, you still have to be thinking, how do I relate them? Because honestly speaking, these formulas are easy. You know them, but they might not come in your mind straight away.
Yeah.
So you need to be
Yeah, they
thinking.
won't.
Yeah. You need to be thinking, and normally for our level, whatever value they give you in the question, you need it to solve it. Like, I don't know if I'm communicating well. They gave you
Oh,
a
so
value.
when they give
Everything
you
you're
in
given.
the yes.
Yeah.
Let's use everything for
Exactly, find a way to use it.
It's giving chemistry.
Yeah. So find a way to use it. They gave you x, but here you don't need x here for anything.
So you have to use it.
So
you know
You need
you're
to-
gonna have
you know-
to do
yeah.
something.
yeah,
You have
you
to.
know you have to use x. So how are you going to use x? You know that SOHCO is there, so you can use it to find y. But there is no y here. You don't really need it. But if you are fortunate enough, if God helps you enough to know that you can relate this to y, you can solve the question. Because if you know y, you can find sine theta, right? And you can find y using Pythagorean theorem. So you put y here, then sine theta will be what? 6 over 10. So you just put that one here. 6 over 10 is the same as 3 over 5. Then you find the theta over the t. That is it. So the process is basically the same, but if you get stuck, like if they don't give you something in the question and you think you need it, you just have to be thinking of possible formulas you've learned